How does a machine know exactly where it is? A conveyor that stops a box in the right spot. A cut-to-length saw that nails the same length every time. A robot joint that lands on the same angle, over and over. The answer is almost always an encoder. In this video, I will show you what an encoder actually is. The two big types, incremental and absolute, and how PLC reads one. By the end, the word encoder will stop being a mystery. Quick note before we dig in. This is from PLC Simulator. You can practice PLC and motion programming free in your browser. Write real code and watch it run. The link is in the description. Now, let's open up the encoder. So what is an encoder? An encoder is a sensor that converts motion into electrical pulses or a position value. It turns mechanical movement into something a controller can count. There are two families. A rotary encoder measures the angle of a turning shaft. A linear encoder measures travel along a straight rail. Most of the time you will meet the rotary kind. It is bolted to a motor shaft or a roller, so that is what we will focus on. Inside, a disc spins past a sensor. The disc has a pattern, and as it turns, the sensor reads that pattern and reports it out. How it reports is the whole story, and that splits encoders into two types. First type, the incremental encoder. An incremental encoder sends out a stream of pulses as the shaft turns. Count the pulses and you know how far it moved. But a single pulse train cannot tell you direction. So an incremental encoder uses two channels called A and B. They're offset by 90 degrees. That offset is called quadrature. By watching which channel leads, the controller knows the direction of rotation. There is often a third channel too, called Z, or the index. It fires once per revolution, a single home pulse. Here is the catch. An incremental encoder only tells you change. It counts up and down from wherever it started. The position is relative, not absolute. So if the power drops, the count is lost. The machine has to find a reference point again before it knows where it is. Second type, the absolute encoder. An absolute encoder solves that power-off problem. Instead of counting pulses, every position on the disk has its own unique digital code. The disk carries a coded pattern, often in gray code, and the sensor reads the whole word at once. So at any instant, the encoder outputs a number that means this exact angle. No counting required. The big payoff comes at power up. The moment it switches on, an absolute encoder already knows its position. No homing, no reference run. There are two flavors. A single-turn absolute encoder gives a unique value within one revolution. A multi-turn one also counts how many full turns have happened, so it knows position across a long travel. Absolute encoders cost more, but for machines where homing is risky or slow, they earn it. So how does a PLC actually read an encoder? An incremental encoder pumps out pulses fast, far too fast for a normal scanned input. So the PLC uses a high-speed counter input, a dedicated channel built to count those A and B pulses in hardware. An absolute encoder is different. It usually talks over a network or a serial protocol like SSI, and the PLC reads its position word through an encoder module. Where do you meet them? Conveyors tracking product position. Cut-to-length systems measuring material as it feeds. And servo feedback. The encoder on a servo motor is what closes that motion loop, the same loop we covered in the servo video. Same device, doing the measuring. So let's pin it down. An encoder converts motion into pulses or a position value. Incremental encoders count pulses, use A and B for direction, and the position is relative, lost on power off. Absolute encoders give a unique code per position and know where they are the instant they power up. And a PLC reads one with a high-speed counter or an encoder module. Get those ideas and encoders stop being scary. Now, I'll go make it concrete. The best way to understand position feedback is to use it yourself. You can practice PLC and motion programming free in the browser. Write real code, run it, and watch a machine track position. Click the link in the description to start free at plcsimulationsoftware.com. Subscribe, new video every Tuesday. See you in the next one.